The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds, and we have Shawn Calderon here, and we're ready to rock it out, man. What's going on,
Hey,
Shawn?
that sounds good, Nathan. I'll have to apologize for my broken camera. I thought I was fixing it, and it's gotten worse. I had no time to fix it, so I apologize, guys. The good news is that you'll be able to look at my slides, and my picture of me will shrink.
Oh, man.
Nathan, are you ready for me to go?
I'm ready to go, man. Here we go. I'm going to pull myself out, Shawn. You're good to go.
Thank you, sir. All right, let's do this here. Let's see. Okay, sorry, something went technical difficulty here. Hey, Nathan, can you see it?
Yeah, I'm good to go.
Awesome. All right, guys, I want to say thank you again for allowing me to have this opportunity to share with you all what's going on in my lab. This is the high point of my week. I look forward to just meeting with you guys and sharing ideas. And so let's get started. This picture here is just to get started. Also, I'm really behind in ordering my slides and videos. So we might bounce around a little bit, but hopefully you can learn something and we'll get through this together. So I started with using the sphere as a source for some more lightning experiments. If you recall from last week, I was showing how if you place a wire over the sphere, that streamers, they call them, that the electricity would come both out of the sphere as well as from the top of the sphere. So you would have this sort of meeting in the middle effect. So I just wanted to show you all the energy that's in this sphere, that this sphere holds in a lot of power, because I'm going to be trying to harness this power for some of the experiments that we're going to go through here in a little bit. And we'll also be talking about electrets and all kinds of good stuff. So just wanted to show you, I named this coil Amber. So here's Amber in her glory. So this is just another picture video. If you guys recall again, the goal was to have the ground up here pull from the sphere here in a point where streamers come out of the sphere.
Hey, Shawn, we're still
Yes.
seeing the MOSFETs.
Oh, we're still seeing the MOSFETs.
Yeah.
Oh, no. Sorry about that.
That's all right. I just want to make sure I catch it early.
Oh, boy. Okay. Let me try this again. I'm going to rechart or reset it here. Sorry.
Yeah,
Sorry,
go
guys.
ahead.
We'll get through this here in a minute. Nathan can tell you how his week went. How his day's going.
My week's good, but I think my daughter just bombed my garage, man. She took the cat in a little carrier, and I think she didn't clean it out.
Oh, no.
Yeah, we need to refresh. Exactly.
Oh, boy.
So.
Right.
There you go. It's a conspiracy. I agree.
Yes. How are we going on the screen now?
I haven't seen it pop up yet, Sean.
Okay. There's the delay, I guess. Interesting. So my day was one of those retired days, retired old man days where I slept in and I had to go to the hospital to get some tests. And if I'm not at the doctor's office in the week, then I didn't have a week. I'm always there. But God's good. My health is working out. I'm sorry, Nathan. This is just. Let me try another thing. Okay.
We can see the slides now. Just click on one and see if it clicks forward.
Yeah, that's what I'm trying.
And click on that first one.
Okay. Can you see the video?
No, we're still seeing all the smorgasbord of slides.
So what I'm seeing is my slides going through, and I see the screens being shared, but you're not getting it.
Do you have more than one of these windows open?
Yeah, let me check. Usually I don't have anything.
Okay, I see your little mouse going over things.
Okay, so you're seeing my screen. Let me try another photo. Let's see here. Is that showing up?
It's showing up on the right of your screen.
Is it? And then I'm on the left.
Yeah, but the whole left part should be gone. So you have two things open at once.
Okay, I am sorry. I can't see here. And let's see. I've not had this before. We just tested this. I apologize, guys.
Yeah, for some reason your computer's split screening it now between what it is you need and what it is. Can you see it that way on your side?
No, I see it working perfectly on my side. So that's what's so unsettling.
Well, shut down the folder and open it up again, Sean.
Yep, that's what I'm doing, sir. And let's.
Oh, we just lost Sean too. No, we'll get him back in a second. All right, guys. We'll just have a little chat until Sean gets back, man. So here he goes. There you are.
I'm so sorry, guys. I'm almost there. I'm just restarting everything.
Oh, wow.
All right. Okay. This should work. Are you seeing anything?
Not yet.
It's showing up perfect on my side again. It says I'm sharing. I'm going to just try something different and hope for the best. It's frozen. Completely frozen. Oh boy. I'm sorry, Nathan. I'm going to need a few minutes to maybe restart my system because everything's frozen. Can you hear me?
Yeah, I can hear you just fine.
Do you mind presenting a little bit while I get this fixed?
Yeah, handle it, man.
All right. Thank you, Nathan. Hey, sorry, guys in the chat. I'll be back with you soon. I got a lot to share. Talk to you soon.
All right, guys. I'm sure everybody feels the same way I do, man. Let's give Sean his time to fix it, and then we'll rock and roll as soon as he gets back. All right, man. Let's talk about some stuff then. We're looking into Electret. From what I understand with Jarvis and everything, the easiest way to build it is put some basically quartz or sand in a pipe and rotate it, and then put in a static field into it. You don't want the positive and negative of the static field. You just want the positive of it or just the negative of it. And then you're going to charge that after time. Shawn likes his little rotisserie device, which is so awesome. And he's able to rotate that and keep the charge going into the circuit. Now, when we say static electricity, doesn't mean you have to pull out a Wilmhurst. You can take 2 DC flybacks. You can put them in series, and then you can actually control the amount of energy going in there, the duty cycle, and the frequency of it with those. If you want to, you can do a AC flyback. It's a little harder to pull off, but you can shorten your voltage multiplier and do it that way. You can also use the taser modules, though the frequency is kind of unchecked a little bit going into those, and they do not like to be run over their value or close to their value, so always try to go a little under that. But they also put it out that way. Anything that's statically charged. Personally, I like the flybacks. I don't have a problem with the heat in them. They usually stand for a good long time. And all you have to do is cool them down, put them in mineral oil when you run them, and you usually do pretty good. I have but the reason I would use that is because I can control the frequency. So, Shawn, we found you back.
Yeah, I rebooted my PC. I had to do it. Everything was going wacky. So let's see. Almost there. Yeah.
Before you open it, present the screen.
Okay. Can you see my window? Oh. Okay, let's try it again. Can you see my window?
Not yet.
It's even showing up in StreamYard on my side.
Yeah, I'm not seeing it on my side.
Okay, start again. We haven't had this problem before. Doing everything the same. I can see you.
There we go. Now we got it.
It finally worked. Okay. Apologies, guys. I'm just going to fill the screen and then change it to make sure it works, Nathan.
Yeah.
Are you seeing now the video on the second slide?
Now we are.
Oh, beautiful. All right, guys. Hey, thanks for your patience. It's great to see you guys in the chat. You guys are the big reason why Nathan and I do this, to have so many smart people gathered together and share ideas. I didn't really have a lot of time to share, to order my slides, so I'm going to be a little out of order, more than usual. And so here, if you can see the sphere I named Amber, I'm going to be using Amber in some experiments. So I kind of wanted to remind you guys of what she can do and how this little 4-inch ball can throw out some serious plasma. And so this is kind of the purpose why I'm playing this. And let's see here. I'm going to try some different ways of trying to get lightning. And I was inspired by Nathan. And so I started these experiments. And if you guys recall this from last week, again, this is a little refresher. Amber's on the left, and here we have a ground. And Amber's just pulling the energy, or the ground is pushing it. I think it's a pump. I think Nathan called it a pump. It totally makes sense. And so you're seeing that in action here. And as I add more voltage, you're seeing that yellow color that you're used to. I still haven't figured out where that yellow hue comes from, but it is interesting. The other thing that's interesting is that on top of Amber is copper wire, and yet it goes through the epoxy. It's one of those strange things about high voltage. is that high voltage doesn't go for the path of least resistance because it doesn't know. And so you'll see the plasma, all its tendrils just start to kind of feel everything out until you get this sort of purple haze between them. And then you're getting from the bottom here, you're starting to get what the scientists call streamers. And so I wanted to try to emulate this with some rocks, dirt, and sand, more sand and dirt, I should say. And so that's coming up. Just wanted to give you a refresher because there was a lot of interest in this, a lot of interest from me as I was doing this. So also, can you guys see this okay? It's not too small. All right, we'll go to the next slide. All right, so this is a little bit change here. What I'm doing here is showing you how to use your oscilloscope to measure your ZVS. And so I'm starting with the diodes, which goes on the input power. And here's the waveform that you should get. You'll notice that, let's see here. You'll notice that this yellow tick mark here on the left at the bottom of these strange wave pattern, and then you'll see the orange on the right here where my arrow is. So what the diode is doing, is two diodes, is it's where it sees it flat, it's cutting off the negative part. And it's only given the positive part. That's why there's this gap here. So you get this positive hump, and it just dips to zero barely. Then you get a positive hump, just dips a hair below negative. And so what they call this is pulsed DC, or half wave rectified DC. And so this is the input power to the ZVS. So when you turn on the ZVS in this way, it just hits the ZVS, then dips, hits the ZVS and dips. But because it doesn't go below zero, or just barely below zero, this is basically a DC. Now, if you have a flatline DC, then you don't get the lightning bolts. You sort of get that puffy ball that I hope I'll have some later in the video to show you. But people have asked me, hey, where do I put my oscilloscope so I don't blow it up? Well, this is one of the places you can put it, and that is across the diodes. So here is a close-up. See, you can see the diodes here where the white arrow is pointing it. And on the left side, the input here is a sine wave. It's just pure AC. When it hits the diodes here on the output side, it gives you that hump pulse DC. It's called a halfway rectifier. So I just want to drill into a few of the tools that are used, because some of you guys are wondering, where do I put my leads, and I don't want to blow up my oscilloscope. Here's another close-up. Here you can see the negative side of the oscilloscope probe on the diodes, and the left side you see the probe across the diodes. And here's a diagram that really shows you clearly how the pulse DC is working. Now I want to measure another part of my ZVS. So here you're now measuring the output of the ZVS circuit. Now the reason why the wires coming out of the ZVS are both the same color, they're both yellow, that's because it's a AC coming out, a high frequency AC. So it doesn't matter because you don't have a positive wire and a negative wire. So you don't need to worry about that. Now, the output of these wires are running about 200 to about 800 volts. And so this can really zap you. I'm not going to say it's not deadly, because everything in electricity is deadly, but it's not going to hurt your oscilloscope if you connect it this way. And here's a drill down again of the output. You're going to get about 15 kilohertz to 500 kilohertz, and you're going to get about 200 to 800 volts. So my memory serves me correct, the oscilloscope is maximum, I think it's 1,000 volts, and standard meter is 600 volts. But I've used this with my standard meter, and 600, 800 volts, it didn't really affect my meters too bad. Definitely, you'll only get 600 volts. It won't read 800, but it's really not a dangerous, going to fry your systems kind of test. And so now I'm connected to the output of the ZBS, and we're going to kind of look at the waves, get a certain wave pattern. And what are we getting here? We're getting an AC, and that's what you want. You want to get an AC. This frequency is wrong, 1.43 megahertz. And the reason is the orange tab up here at the top. I haven't adjusted this, and maybe my oscilloscope needs to be calibrated, because this is wacky. There's no way it's 1.43 million megahertz. But I wanted to show you what it should look like coming out. So that was kind of the important thing. Connected to the output, and then your oscilloscope, and then fiddle with it until you can see the proper field. I'm emphasizing that again here. Here we're connecting it again. I think that, this is a change in adding coils and capacitors to resonate. So this is another kind of waveform that you'll see on the output. And now I'm going to connect it to power amber. And so now we're going to measure what that power looks like, amber. Now I'm hitting the auto button on my oscilloscope so it can try to lock in to the sine wave. Now, if you recall, the sine wave output was very smooth, but now that you're seeing it here going into amber, the plasma sphere, you're seeing that it's a little goofy at the tips. And one of the reasons why it's a little weird at the tips is because the the chokes, those round spheres wrapped in water, you can see them on the left barely. See those? They look like little wheels. They don't have enough inductance to absorb the changing magnetic field. And so it's sort of getting saturated at the top of the AC wave and at the bottom of the AC wave. So if you added bigger of chokes, those toroid round coils, then this would smooth out. But it's not too bad to work with. Nothing's perfect in life. It's good enough. Now I'm working on Electrets also, and on the left, I ordered this power supply, and it goes between 1,000 volts to 10,000 volts, fits in the palm of my hand. And I've done some work with it. It has a little tiny, maybe 1-inch spark, but it's mostly creating a static field. That's what this is all about. And I thought, I bought this for 17 bucks, but they have one that goes up to 60,000 volts. I thought, in the picture, it looked about the same size as this one, and it was a little more expensive. So I thought, well, I'm going to order it. And, and let me see if I can see the play button here. And it came in the mail, my new one, and it is ginormous. I mean, this thing is huge. You probably could put 12, 15 of the other ones in this box here. Now, the cool thing about this power supply, not only is that it goes 5,000 volts to 60,000 volts, which is DC. So this is very, very scary. It has 10 milliamps, which people would think, oh, that's nothing. Yeah, normally 10 milliamps with 24 volts is not a big deal. 30 volts, not a big deal. I mean, you probably go up to 60 volts, it's not a big deal, shocking you. But 10 milliamps at 5,000, between 5,000 and 60,000 volts, that's very dangerous, very, very dangerous. So the cool thing about these power supplies is that they're not only inexpensive, but you can fine tune the output voltage. And the purpose of this power supply and the other one is it's to electrify paint droplets, actually paint molecules. And so if you use this connected to your spray painter, what it's going to do is each molecule of paint is going to land on the surface. And because they're like charges, they're going to sort of stay on but not jump on top of each other. It's going to be very thin and it's going to be very even coat. And I thought, well, if this can ionize paint molecules, it also does powder as well. It can ionize powder. Then why can't it ionize the stuff that I'm using to build electrets? So that was my thinking when I got this. But I need to develop a very safe area for this power supply, because if I don't have multiple layers, then I might be dead before I hit the ground. That's how dangerous this thing is. This is a close-up if you guys want to get the specs and order it. And here's the side view. What I'm going to do is I have that high voltage probe that I made. I'm going to hook it up and to a voltage meter, and that way then I can actually get exact voltage details. So that's going to be my modification. But this thing's a beast. So if you remember about what's called the triboelectric series, and all that means is there are certain things in life that have the propensity to grab electrons. They kind of want to grab electrons. And so that would be a negative on the triboelectric series. That'll be a negative material. If my memory serves me correct, these are negative materials. I might have to check my notes. And then there's the positive materials. So they have the tendency to give up electrons so they can become more positive. And so I was taking these materials because I wanted to use them in some experiments to build electrets. Now, Brent Jarvis, he said that we need to learn how to walk before we run. So this is all run or sprint. So this is a little bit ahead of the game, but I thought I'd share kind of what's in my setup. Now, I shared with you also, I'm working on the Tesla coils, and I'm working on getting to low frequency Tesla coils. Nathan has emphasized that that's where the possibilities come when you're, you're lowering the frequency of the Tesla coil. And so what you're seeing here is I'm taking 1/8" pipe. It's used for refrigerants, and it has a really tiny hole. It's like 5/64 of an inch. And so what I'm doing is I'm just soldering my circuit together. And the cool thing is you can take the components and slide them into these openings, build a little structure, and then you don't need a circuit board. Now, the reason why I'm doing this and not using a circuit board is because this setup for a Tesla coil, it gets high currents and it has voltage spikes, and I mean, it just beats the heck out of your circuit board. And so I thought, well, I'm tired of the circuit board not able to handle the currents, and so I have to buy a new circuit board, and it just gets old real quick. So I thought, okay, I'm going to use these two terminals so that way I can swap out these MOSFETs, transistors here, whenever they fail. But everything else here is going to be soldered together, but able to be replaced. So kind of a plug and play. Let's see here. I named this circuit Uber 3 because my first one I shared with you barely worked. Second one, it worked really well. And so this third one, I'm just sort of streamlining it now. I'm almost done, but you'll notice I make some kind of changes to how the wires are bent on the transistors, because when I put this thing together, each one is different. As I put things together, it's going to make sense, and it's just going to be kind of a work of art. I think someone said steampunk. So I have a lot of pictures of this. So I tried to draw the minimum number of pieces that you can build this circuit with. So this is the minimum that you need. Let's see. And here are the components. And so I talked about these circular coils, they're called chokes, how they need more inductance. When I take off the wire here, I reduce the inductance. These start out as about 110 microhenries. And taking one turn off with these wires to make the leads long, they are now 100 microhenries. Let's see. Now I have this thing, it's the idea box, and I have sticky pads everywhere. So I grab my Sharpie, I'll write my idea around, and I throw it in my idea box. And this allows me to not lose ideas. Because I don't know about you guys, but I think it's probably the same because you guys are all smart in the chat, and I know Nathan's brilliant. But ideas come flying out of nowhere, and you're working on something. And you don't really want to stop working what you're working on, but you don't want to lose the idea. So I have these sticky pads everywhere, and I just write the idea super quick, put it in there, and it sort of relieves that pressure that I don't have to hold it in my memory and go back to what I'm doing. And then when I'm in the mood and my health is up, I'll just pick an idea out here out of the box. And so I thought I'd share that because this has really helped me compartmentalize my approach. There's something called context switching. So if I go from soldering down here on the Uber circuit, and then I go down to writing in my notebook my idea, when I come back to work on the Uber circuit, I'm totally got to start over again. Where okay, what was I doing? But if I have the sticky notes, I can throw the idea on and toss it in a box. I can go back to soldering or whatever, and my brain doesn't have to make that switch. So here you see I'm putting the diode in, and you're seeing now it just sort of comes together like Legos. So here are both the diodes now. You're seeing the resistors on the bottom. And that's as far as I've gotten. Now, talking more about Electrets, I don't know if I shared this with you guys last week, but this is used for polishing jewelry. I picked it up pretty cheap. Verver has really good stuff. And what I'm going to do is I'm going to start putting things inside this tumbler and see if I can make material more positive. And we have glass. This is glass powder. And see if I can tumble them and increase the electrostatic field and do measurements, get a feel for how it's working. And again, I need to get close to the elements. I need to have things in my hands. I don't do really well with a lot of theory. I do really a lot better if I just get on the test bench and start throwing things together. And Jar Jar is so patient with me. He's such a great guy. He just gently says, yeah, that doesn't work. Or you're on track, but do this. And I'm completely off and I have no idea what I'm doing. But this is the road I'm taking. And I'm hoping this gives you guys ideas. I got my electrostatic meter taking measurements to make sure that when we measure it again after I tumble it for a period of time, to see if its electrostatic field has increased, and it's about 1.9 thousand volts. And that sounds like a lot, but we all hold electric fields. Everybody has an electric field, and they're at different densities or different pressures. That's about a better way to say it. And so even though I'm measuring 1.9 thousand volts, measuring the side of this, there's almost no current. I mean, when you talk about small current, usually people think of milliamps. If you're thinking about really small current, it's microamps. And then if you're low microamps or high nanoamps, that's pretty much nothing. And this is probably high microamps or low nanoamps. That's why it's got voltage, just harness it. When you have a billionth of an amp, it's just not gonna do anything. It's just gonna stay as a static field. So I'm doing my measurements inside. Everything's upside down with the meter, but here you see it's about 520 volts. Didn't even break 1,000. I have a book designated to Jar Jar because I have to write down all the good ideas he sends me. And so this is a tribute to the master. I also have a notebook for Nathan and another one for Ian. So don't feel left out. And anybody else that's working with me, I have a notebook. But here we're doing Electret's work, so I want to let you know. So now it's been tumbling for some time, and at first the glass powder was not sticking, but now you're seeing the glass powder stick. And so you can already tell then the voltage is increasing because now the glass is drawing a field that's attracting it to the strangely angled container. And so I don't have the video of this at 0 volts, but I started measuring it on the side after about 15 minutes. And here you can see we're getting 9,000 volts. I thought that was interesting. And I'm not even measuring the inside of it. But what's going on is that you don't really need to touch things with electrostatic fields. You just got to kind of be near them. And this is something that's very important. Now as it's building up, now it's 12, 13,000 volts. And what does this mean? I don't know. It means something is getting charged, and I'm going to find it. Okay, so my slides are out of order. So what I did is I ordered a IGBT, and IGBTs are the rage with all the Tesla coil designers. I mean, if you're using MOSFETs, then you're not a part of the cool guys club in Tesla coil building, because all the cool Tesla coil builders are using IGBTs. So I decided to order an IGBT, and IGBT is just another transistor. MOSFET is just another transistor. So, I mean, don't think that they're something completely different, but they're in the transistor family, I'll say that. So I have this little Oscilloscope cheap transistor reader. This thing is awesome. One of the best things I've got, and I use it to test all my transistors. And now this came out of a stereo system that I took apart from the thrift store. It's a transistor PNP. And then this is what, oh no, wait a minute. This is another transistor. Okay, that's what it looks like. Oh no, where's my IGBT? Sorry, I need to go back. My slides are terrible. We'll get to the IGBT, I promise. I'm so sorry. Basically, the ITGB just looked like two diodes. That was it. It just looked like two diodes connected. Now, I open this up. This is run for 30 minutes. And see how the glass particles are sticking to the glass? When I poured it in, they didn't do this. The glass just fell right to the bottom. So there was no real rubbing action that would cause an electrostatic field, or what we call here an electrostatic cling of the glass powder. But now it's really had some kind of attractive fields that's caused it to the sides of these walls. And I'll tell you what, it's really stuck. I mean, this glass, they're tiny round beads. So I don't want to get anything that could cut me. But I'll tell you what, it was really hard to try to take these off, because what happened is as you scrape them, the field was so strong as they would jump out of whatever you're wiping them with and come back to this material. So that was not fun. But what I wanted to do is do some readings. Here I'm trying to ground it out. Hey, maybe I can remove the static field so they'll fall off. And I'm having no effect, as you can see, but it was worth trying. So I thought, you know what, I'm going to wrap it in some aluminum tape. And then hopefully, as I begin to run some electrostatic fields, maybe the glass will stop clinging. And so again, this is sort of stream of conscious. This is what I just sort of fiddle around in the lab. I'm so thankful, guys, that you like to take this journey with me. And so here, okay, I've gotten the aluminum tape. Now it's time to see if I can put some electrostatic fields using this tape and maybe nullify the fields that are causing the glass to cling. So here's one of the things I'm doing. I have my cool Wimshurst that I picked up from Amazon. And it's really cool because as I've been running it, one end connected to the tape and the other one, look, it's just cleaning up the walls. So this is really cool. I was able to charge the glass, and then I used the Wimshurst to then remove the charge of the glass particles. I think that's important learning for me because I have to really figure out how charge works. And this was an example. This was charged up about 13,000 volts, as you saw earlier. And now that I use the Wimshurst here, the Wimshurst is, and this is the real polarity too. The red alligator clip was the one that helped reduce all of the glass. And I started doing it earlier and it got rid of it. But here I just kind of wanted to show you how cool it is. Pretty cool. So the glass beads, you can put them anywhere. And I wish you could hear this, but things move and they make sounds. So if you were to just take this metal bar, hang it by something, and then tap it, it makes a sharp noise. But because it's on these glass beads, I was finding that this was hitting a really loud frequency. And so I thought about how maybe it'd be worth running experiments with these little glass balls, because again, everything just moves around as if it were on air, floating on air. These little tiny ground, they're all symmetrical, almost glass balls, and they're very tiny, but they're very strong. Again, here's the new Wimshurst. I love it. And I think I'm going to use it here to clean up. Because I don't have the tape, though, I don't know how well it's going to go because it's just connected to the plastic now. Now, earlier I had connected to the metal tape. Here now I'm connecting it to the plastic, so it's not really having that same kind of effect. And so, but I thought I'd share. As with my other hand, I'm turning the Wimshurst, building quite a charge, and I'm feeling the charge as I'm doing this. Pretty cool, pretty interesting. It's sticking now. I don't know why. It wasn't sticking before. And there I discharge it to show you. All right, so these 1/8" pipe, when you cut them with the little cutter, you have to dig out the hole just a little bit, just to widen it. And that way then your diodes will go in, you can put it in your transistors. So this is just kind of little tricks that if you just buy the 1/8" tubing and you snapshot some of my photos and video here, you'll be able to build this thing. And it's only 10 components, and yet it's a powerful ZVS circuit. So here I'm kind of showing you how things fit. Before it didn't fit, and now it does fit. Good stuff. Oh, there's an IGBT. But I'm not getting the wave output. All right, so this is something I'm building with IGBTs. My goal here is I think I can build a ZVS with just 2 IGBTs and 2 capacitors, and that's it. And so that would reduce the 10 components for the ZVS I'm working on down to 4, and that'd be really amazing. So I'm working on this. It looks positive so far. I just thought I'd share with you. It's just one of the projects I'm working on. Here's another look at it. I'm really determined to get this thing working because if this could work this way, it would really blow people away. Also, too, the IGBTs are supposed to be more powerful and handle switching better than the MOSFET. So now that I have my Wimshurst, I also ordered a Van de Graaff generator from eBay. Now this is a Russian made, and it's pretty old, so it was inexpensive. So you could pay $1,000 to $2,000 for one of these, this quality. And I think they're selling them for $200. I'll have to check. But this is coming, because this thing can throw lightning bolts the same as the Wimshurst, but every second. The Wimshurst, you have to wait every 4 turns of the wheel. And here we go. And I think one of the reasons why this is so cheap, you can see the band there. We scrape that band and we get the electrons being shooting out. It's the rubber band that is the source of the power. Little crack injury and shipping, no big deal. So here they are together, the Wimshurst and now the Van de Graaff. So I have really good sources now for static electricity. But also, if you saw earlier, I had that big box for the ionization spray painter. So I'm really trying to diversify all my different types of electrostatic fields, because I'm really excited to get Electrets working under Jar Jar's help. It's another picture. Let's see here, up close. Thing's not very big, but man, when I turned it on, it lit up everything. It's about 22 inches, not bad. All right, so if you guys remember earlier, it was Nathan's good idea to say, hey, you know what? Try to simulate lightning hitting the earth, actually. And so what I did is I filled up that sphere full of sand, and I took amber and took a very thin wire and placed it very carefully over the sand. This was very hard to do. The reason why it's hard is amber is very balanced. It's a balanced system. And if I take a long piece of wire and connect it to the top of amber, I offset that balance. It increases the inductance, and then I have to go retune everything, and I don't want to do that. So what I did is I used a very careful small wire, and what I'm trying to do here is lay a length of wire and kind of simulate how clouds move across the sky. And so what you're seeing here is that this is a cloud, and it's building up all this charge because it's running into other clouds, or it's hitting hot air and cold air. There's a lot of ways of rubbing that builds that electrostatic field in the clouds. And then all of a sudden, it gets so much charge, and boom, it hits the earth. So you can see that effect here. It's actually hitting the sand. The sand's about a half inch deep. And it's pretty fascinating, pretty interesting. I'm going to keep trying this because I wasn't really satisfied. I really wanted to see the streamers. And so I'm just kind of banging my head against the wall working on this. But you can see this super thin wire. See here, it's a super thin wire. I had issues with focusing, so I'm probably going to go quick if these get blurry. But again, I put a little turn in the wire. I'd changed the voltage, and I really just wanted to emulate what are the clouds doing on a thunder cloud and cloudy day. Again, they look similar, but I'm trying different voltages. I'm trying slightly changes in the wire, and it kind of looks like a thunderstorm, but it's not from the bottom up. It's sort of just from here down, the wire down. It's important to note that if electricity were to take the path of least resistance, then you would not see all of this blue and all these little tendrils and all these little mini lightning bolts. You wouldn't see them. As soon as the lightning bolt would hit, all of that should be discharged into the ground. But see, electricity doesn't take the path of least resistance because it doesn't know that there's a lightning bolt over here. It's something that they learned that fascinated scientists when they studied lightning. I put a piece of mica here on the left. That way, mica can take the hot temperatures of the plasma, And now, again, I'm just stringing it out, different distances. Again, trying to just simulate lightning. I put some areas of sand, kind of emulating maybe valleys and grooves, and this is what I came up with. What's super not easy to set up, super not easy to film. For every film you're seeing here, I had to make 3 that were blurry. For some reason, when that little lightning bolt hits the ground, I go out of focus a lot. Now here I'm using a real straight piece of wire because I kind of wanted to see um, more focused energy to try to really pull up a streamer from the sand. And so that was my attempt here. I also want to kind of show you how charge just dances on the wire. I thought that's interesting. This wire is magnet wire, so it's actually insulated. And so what's happening is the high voltage is just kind of dancing on the insulator. It's not supposed to do that. Electricity is supposed to stay inside. And but that's one of the cool things about plasma. Here again, I'm really trying to say, okay, let's focus the energy and try to get the ground to produce a streamer. And so here I am. I'm filling this whole valley here with blue glow, just saying, please, sand, please come up with a streamer. Now I'm using a wire that has plastic coating, and now I'm really getting serious. But even the plastic coated wire, you're seeing a little bit of guys escaping, but it is more focused. And now that I have this really focused, I feel like, okay, now I should start seeing streamers. And let me see if I can do this here. Let's see. Let's see if I can do this. Will it work? Trying to see if I can go frame by frame and look for that streamer. Let's see here. Look for any streamers. Okay, here we go. All right, come on, let's see. Because this is the fun experiments that I like to do. It's very tedious, but I'm hoping to see a streamer here, guys. And I know I'm going long already. Oh my goodness. Let's see. Come on, there is one. Just want a still frame. Okay. We'll get there. And by the way, I'm increasing the voltage super slightly as I'm going ahead here. So, oh, there we go. There's one. All right. So you're seeing, this is what I thought was fascinating. When you freeze frame it like this, the lightning doesn't look like it's shooting straight out. It actually has that twirling action as it hits the ground. Now, there's no twirly action on the, I'm so technical, right? Twirly action. But this sort of twisted streamers. But I get one when I connect to the sand ground. And I thought, oh my goodness, that is a place to do some researching because that is incredible. Something I could not see when I was watching the videos. So here's another one. You can just see it sort of twist to the ground. And so this gave me a little bit more close-ups of the simulated lightning because it was just barely enough power to have a lightning ball, lightning sphere. Oh my goodness, if I had a lightning ball, I would scream. And so again, these don't look like lightning bolts. They start to twirl. And so that's something I did not see in all of the videos that I made, is that you get this twirling action. That's pretty awesome. So maybe you guys have some good ideas in the chat, or I know Nathan catches things that I don't see. So it'd be good to kind of see what he thinks. But let's see if got some more stuff here. I think this is another one. Probably trying different voltages. Yeah, I'm increasing the voltage because you can see it all dancing. And so this one's pretty interesting. Let's see here. You guys tell me if I'm going too long. I'm kind of having fun here, but I don't want to go too long. Let's see here. Can I do this? It's interesting. Here we go. All right. I want to see the tendrils on this one because this one has multiple tendrils. Come on, you can do it. If this will work. No. All right. There we go. Oh, perfect. All right, let's see. So more tendrils. As I increase the voltage, I'm going to get some multiple. There we go. So even when I increase the voltage, you don't have clear, thick lightning bolts. You have this sort of fuzzy yellow twisting tendrils, and pretty cool stuff. I'm going to be doing these simulations with all of my high voltage power supplies. But I had amber all set up, so I thought I'd just do amber. My health was really poor for a couple days, so I didn't get a lot of time. Otherwise, I would have been doing more. But I'll have some real serious lightning experiments in my next presentation next week. So I think I added water here because, of course, when you have a thunderstorm, there's water. It's raining. And so I added a little water, no change really. And there's my blurry problem that I suffer from in most of my videos. I guess the only thing about water is you have these stringy white tendrils. You don't have the blue fuzzy ones. So I guess that's different. And I wonder if, see if I can pause it here. No, my mouse. Here we go. Let's see what the tendrils look here on the water. Here we go. Come on, hit the water. So yeah, so they did get stringy. I just saw that. All right. So the tendrils go away. The twists go away when there's water. Isn't that interesting? That's really interesting. Let's see. Here we go. Look at that one. Fascinating. Let's see. Yeah, there's definitely differences. I didn't pick that up when I first filmed this. Doing a little bit more higher voltages, probably. Put a little closer. This one might be interesting. This is I'm cranking it up. That's what I'm doing wrong. Okay, let's see. Now that looks more like a lightning bolt. Really does. This got by me. Just a straight. Now the yellow hue is not lightning, but it's definitely not twirling. Wow, that's cool stuff. Super cool. Kind of wanted to show you what it looked like. Oh, here I put foam under the sand. I really wanted it to be away from the water again, and I wanted to see if it had a real thick insulator under it. It does look the same as prior, so no big differences. Let's see here. I was playing around with things, putting it under there. Let's see what this is the foam again. Here we go. Oh, that's what I wanted to show you. The foam under the sand is kind of a middle ground. It has some twirls in it, but it's not those thin streaks of lightning, and yet it's not that sort of twirling vortex looking. So kind of in between. Interesting. This is the same thing. Okay, so this is when I tried to go slow-mo. Let's see how it came out. Yeah, it didn't focus. Sorry, guys. Let's see. There's something I found out too. Nope, can't do it. I was going to try to slow it down, the frame rate. High voltage, cranking it up. And so now I was just getting silly. I had a pancake coil. I thought, what it looks like with a pancake coil. And I mean, just looks like metal attracting metal. I didn't get any streamers, so I was kind of bummed again. It seems like I have to go back to the drawing board with us getting the ground to give up electricity and meet in the middle. So here I'm just goofing off. And oh boy, that's it. I think my stuff's glitching because I had more Electret stuff. Sorry, 1 second here. Let's see. That's it. Well, hey, well, thank you guys. I have a whole lot more to share, but it looks like it's not going to be able to happen. I apologize, but we have probably some stuff to talk about, Nathan. If you want to bring me back in.
Yeah, I'm here. That looks totally awesome, by the way.
Oh, I appreciate that.
Yeah, the water on it making the actual straight lightning out of it was awesome.
Yeah, that got me.
You put a little fog in there with it. You know what I mean? With the tendrils. I was wondering if it would swirl out and start tornadoing on you, or
Yeah.
add a secondary charge on the outside of a little bit of static when you put that in there, because you need both. You need two fields in there in order to create that tornado.
Oh.
So yeah, you may like a kind of like a thin static charge on the bottom. You know what I mean? And
Right.
then that little bit of mist in there. It's just an idea.
I'll definitely try it. I think it's a good idea because that's what clouds really are. And I think also to be super accurate with lightning tests, it would be off the Wimshurst or the Van de Graaff or that electrostatic power supply for paint droplets. I think those are going to show a little bit more accuracy. So I'm going to get those on these lightning tests, and then I'll get one of my wife's spray bottles, the fine mister ones, and I'll just add a little mist, like you said, when I'm doing this lightning testing. Large surface area.
Yeah. So what would be cool, Shawn? Take you don't may not even need the machine. If you could build a 6-inch by 6-inch Electret underneath and get the static charge in there, and then build up the sand and dump it in there right before your test. You know what I mean? Then see what it does. Like, you may even see the tendrils come up from the bottom because of the static, and then it'd come up to meet it. That would be awesome.
That's a good idea. I'm writing it down. Yeah, it'd be totally awesome. I get a lot of my good ideas from you and the guys in the chat. Guys, thanks for hanging in there. So Nathan, what did you think of the tumbler idea and trying to create materials that hold a big static charge?
Oh, I think it's awesome. I think once you understand each material, you're gonna be good to go to create whatever you want.
Yeah,
It's kind of the key to it.
yeah, and I haven't added heat, like you said, and I haven't added sound, vibrations. So those are things that make Jarvis's patent unique, because he not only does the obvious, try to charge it up with the power supply, but he says heat it up. He says make it roll around, then hit it with vibrations from sound, and just all of these layers. And the key is that if you can cover each little glass fragment, if you can cover the entire thing with static electricity, and then you have, let's say, 10,000 of them, that's when you're going to have Electret. It's all about surface area. When you rub silk on a PVC pipe, and the more you rub it, is the more silk you're exposing to the pipe. So if you rub it 10 times, then silk has more charge on it from the pipe. And so that's the idea, is as you tumble it, you're placing a charge on each little end of the particles you're tumbling. Each one of those pieces of glass becomes an electret, and then they add to each other. If that makes sense.
Yeah. Interesting. Yeah, I can see that. You tumble more, the more it gets electrified, the more that it charges together. That makes all the sense in the world.
Yeah, and that's really the good idea with Jarvis. Now, to make an electret is hard. That's step one. Step two is to make stronger electrets. Then step three is, and I'm just pulling this out of my butt. I know Jarvis will correct me. But then let's see. Then you try a monopole. That's actually what we're trying to work toward, is the monopole. Because the monopole is only one charge. And so, you see those pictures of one charge, and all the charge leaves it in straight lines all the way around it, like spokes on a tire. And to have millions of those spiking out added, and all you have is a monopole with just powerful lines, single lines of charge, and you won't have any mixes of charge or bending of fields or bending of waves. It would just be this, what he calls the monopole, if that makes sense.
It does. So here's the thing I would say to you, and I know Jarvis is the expert, but beeswax it first. Go with a fast set. You know what I mean? Some of these things are slow sets. Go with a fast set. And the reason I say that is because you really want to see what each thing does, and then test it out a little bit. You know what I mean? You may not get a lot of time with it, but you'll get a little bit. So you're going to find out real quick some things are better than others. You know what I mean? So they're worth your time in investing. Some are not. You know what I mean?
Right.
Some things have to be like charged longer in order to get the correct amount, out of it. So there's variance in all of this stuff. So yeah, I think that's the way I would go with it. And then don't be afraid to try things. And I must say something very silly to you.
Okay.
It's like wrapping your wife's pantyhose around the tumbler, and then put the Wilmhurst right onto it. It literally, you're making one out of it. You know what I mean?
Yeah.
You're literally creating the static generator out of the whole thing.
Interesting. I didn't think about that. I mean, pantyhose is what are they made? What is it made out of? Vinyl?
I'm not entirely sure, dude. I don't know much about them. I just know that I see the videos and they start using this stuff all the time. You know what I mean? I mean, you could literally put it on the bottom ball, wheel of the static generator and hook it right to it, and then put the wires on there and light it up. You know what I mean? The brushes. Yeah, I mean, it's probably a long, drawn-out process compared to this. This is probably just as easy, but made of nylon.
Ah, gotcha.
So anyway, myself, I stick to the simple basics. Throw a little tape around it, aluminum foil tape, and then hit it with the static, and you're good to go. Or just run the stuff the way you do.
Yeah.
But I thought it was interesting. The electricity cleared it. That was pretty cool.
Yeah. My lightning, try to simulate the lightning was not what I expected. I didn't expect it to go into that vortex twist. And that's something, I mean, you pointed that out in my first presentation when we met us almost a year ago, right?
Mm-hmm.
And that tendrils as lightning, that surprised me. I thought it was just going to be those straight lines like it was with the water. What are your thoughts on that?
Well, yeah, that water straightened it right out. And I thought that was amazing of it. I think you have to remember which one you're doing. So if you did one with tendrils on the bottom, mimicking the negative side in the earth, and then a top one with regular Tesla coil voltage, mimicking the hot area, you may get a surprising result if they contact each other. You know what I mean?
Yeah.
Because I know I thought I wouldn't get much of a result when I took taser things and put them around and
Yeah.
started those up, but then I ran DC high voltage through it, and the amount of energy was like exponential, man. It just boom, it increased like crazy.
Oh, wow.
So it's kind of weird stuff like that happens in your lab that makes you try different voltages against each other.
You're the king of that. I've seen your videos where plasma's coming out of everywhere, coming out your ears.
Set a couple things on fire. Yeah.
Yeah, yeah, that's I've been there many times. So some guys have some questions in the chat. Forgive me if I'm a little behind, guys. So let's see here. Let's see. A lot of nice things in the chat. Thank you, guys. Love you guys back. Thanks. Right, so start here. John Bigman, just be careful. The plasma channel did that and had issues with the water condensing on the system itself and shorting out. Yeah, that sounds right. You don't
Wasn't
want
he running
water.
his in a tornado in a tube?
He did that with the gas, right? He put some gas and then the static field made it into a tornado.
No. He took the static field and ran it through his thruster, which he reconfigured, and it went in
Oh,
there, and he's put the water in there, and then it tornadoed on him. I'd check out that experiment before you do another one.
the water tornadoed on him?
Yeah, that's what he was doing. He was doing like a water tornado
Oh,
thing.
that's the that magneto hydroelectric or something that way, where they use magnetism as propulsion in water, something like that. I'll definitely have to check that out.
No, that was a different one.
Oh, it was a different one.
Yeah, we're in a different one still. He has a tall container, Shawn, like this.
Yep.
And then he puts them like on the sides. There's like, I want to say there's 6.
Mm-hmm.
And they're putting it in there in a twisting formation. So it's already getting the tornado. So yeah, check that one out.
I will. Tornado's probably in the title.
It might be. I'm not sure. I'll find it and send you a link.
Oh, you're awesome. Okay. Sounds good.
Let's see. Charlie C's got something for you here.
Okay.
I tried to make Shawn's indestructible ZVS, but when I powered on the 12 volt, there was a short in the circuit somewhere because it draws too much current.
I haven't seen that. So Charlie, I'd be glad to offline we talk about this on Messenger. You can send me some pictures because I haven't had that issue on any of my 12 volt setups, and I have about 15 12 volt setups, and they all don't short out. So I'd be glad to look at your circuit. So good question. Thanks for sharing. So 3D Havoc says, isn't there a way to create fog with electricity? I think I saw something on YouTube that did that.
You could move fog. You could pull water out of the air.
So like a condenser of the moisture in the air.
You could pull it right out of the air. Yeah, Plasma Channel does a lot of that stuff. Pretty cool.
He's saying the opposite. He's saying, can the electricity put fog out in the air, not condense it? Puts it into there.
It can create fog if you know how to do it. Yes. Maybe not the traditional fog we're used to seeing, little green fog. Yeah. But
interesting.
It would take some work to do it, though. Yes.
Yeah, I'm trying to think about it in my head, and I'm just not sure. Um, I mean, other than boiling it, but that's that's, that's not what he's asking here. So, yeah, I think it would take a lot of work.
Yeah, because you're basically in a dry environment trying to create moisture in the air. If there's a little bit of moisture and you're pulling it towards you, it's a lot easier.
Right, right. Yeah,
So yeah, you're trying to affect the molecules in the air in order to produce the water. So that's going to take a heck of a field.
yeah, exactly. And 3 Hawk does say later that you can have a fog that's charged. Yeah, it'd definitely be charged.
Yeah,
Um,
Jarvis says ultrasound, not boil, but ultrasound. I've run one of those
oh,
ultrasound cleaners, and I haven't gotten much to come off of it.
interesting. Interesting.
Oh, with the aroma diffuser. Well, that might be the difference right there.
Yeah, oh, he's right. Good call. There's a little atomizer, and that atomizer is, I think it's a piezo, and I think that piezo is moves back and forth at a certain frequency, and that breaks up the scented. Oh boy, my camera's failing. Oh my goodness. Sorry, one sec. I'm not even in focus. I am so sorry.
Oh, Shawn.
I told you it was dying.
Oh, I guess I'll get you a new camera. This
I'm
is
so sorry. I hope this is not a distraction.
it's all good, man. As long as we got you, man. Oh, yeah.
I
You
killed, yeah.
killed the camera.
And it's funny because I had it all set up. I fixed it. No, 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 no. And this is a new camera, so it's heartbreaking. But I'm sending it back. No way.
Yeah, I got one of those Razer cameras for mine. It works perfect.
Nice. I'll get that. I think I got the cheapy Logitech. You got a Razer?
Yeah. So the only thing I dislike about the whole thing is when you sit there, it auto focuses and sometimes it gets blurry. But then when you set it, it sets at a lower setting, so it goes down to like 720p or something.
Oh,
It's frustrating. That's the only thing I think is wrong with the camera. Other than that, leave it alone and you keep the same distance, you'll be all right. That and it doesn't like high voltage as much. Remember those experiments I was doing? I got the camera to blur out on me a couple times.
that's why my lightning recordings were blurry, because it was the electric field was focusing and unfocusing for me. It was
Hey,
it
Shawn,
was
try turning off the light to the room.
I just turned them on. When I turned them off is when I was blurry.
Oh, okay.
They were off. Yeah, I was sitting in a dark room. I mean, I'll try it again. My room is dark now. Is it better?
It's about the same in the camera.
Ugh.
But now
Okay.
you're not all whited out. I can actually see you pretty good now. Getting better. Oh, yeah, he's good now.
Well, I don't have a nose, but I do have eyes and a mouth.
Oh, it's so great.
I look like one of those Thumby. All right. The Egyptian DJED was
Okay.
a dipole conjugate ceramic cone ether modulator, likely for terraform tapping from the electro potential ley lines. Woo, Jabber. He should not be Jabber. He should be something like Professor or something.
Yeah, that's what I'm thinking.
He's got some, and if you think about his run-on sentences here, just kidding. They make sense.
Mhm.
It just you have to, each word is like a sentence. It's how deep he thinks.
Like a Rubik's Cube, you got to twist it and put it all together.
Yeah. Yep. Oh my goodness. Sorry, I'm fading away. Anthony Williams says, do a discharge a few feet away. I've seen lightning trigger the lightning a large distance away. Interesting. I do want to grow the lightning bolts, but it's not easy. I mean, you need more and more voltage. Right. So John Bigum says, yes, Munkles used sound to levitate things like they do with transducers now. Oh, monks, I think he tried to say,
Yeah.
not Munkles.
Yeah,
That's
we've all seen that
interesting.
thing with the monks, man. We'd all love to pull that off in our backyard, wouldn't we? I mean, nobody wants to shoot a rock across the yard or over your fence, but hey, in the name of science, I'm here for it. You know what I mean?
Yeah. I'm fascinated with the transducer levitation. Are you familiar with that? How that works?
Well, transducer levitation is basically sound levitation. So it's like little speakers. They go in a directed format. So, you know what I mean? The little styrofoam balls ones.
Yeah. Makes total sense. Thank you.
They also had an older one that used sonic sound or something like that, and it swirled balls in a circle.
I've
They
seen
built
that.
it for NASA. Yeah.
Sounds a pretty interesting thing. All right. Anthony Williams says maybe the first lightning X-ray and UV burst help trigger the second. I wouldn't know how to add X-rays and UV bursts. I could probably do UV bursts.
Well, you're going to get it right out of your plasma. Depending on how
X-rays.
Yeah, depending on how much you got out of there, yeah. You're gonna get, because it's radiant energy you're playing with. I mean, you're just playing the positive, negative side of it. It's basically, if you put it too high on your Tesla coil, you're going to be getting some X-rays whether you like them or not.
Yeah, yeah.
That's why when somebody says I want to put 400 volts on a Tesla coil, I go, you do that miles down the road, buddy. Stay away from me.
And if you want to have kids, you got to put on lead underwear. I mean,
yeah, you got an aluminum chonies. There you go. Huh. Oh, maybe
right.
put a padding later because the aluminum may be hot. Oh.
A little suit of armor, a little aluminum foil suit of armor.
Oh my God! Now we're doing out LARPing. I'm gonna get my little sword out. You know what I mean? My little lightsaber. We're going LARPing. Oh, that's amazing. Oh.
All right. Bigman, whenever matter is in conjunction with the ether, it becomes stronger. So affecting the ether is only a matter of affecting the atom itself, like he did with his tower by pumping the ground. Ether's coming back. Ether was proven wrong supposedly in the 1920s and 30s. And now, if you read the latest physics, it's come full circle now because ether seems to explain dark energy and dark matter.
Well,
and
hold
it's kind of funny. The fringe scientists seem to know this already, but the mainstream have totally made a U-turn. And tinfoil diaper, love it, Ulysses. But yeah, it's interesting. I'm not sure what entirely John Bigham's saying here. Ether in conjunction with matter.
Okay, so hold on. I need to clarify something.
Sure.
The ether theory, by what is it, Lorenz? It was messed up because they're just using basic magnetic form to create the theory. So when we talk about it, we're talking about negative energy. We're talking about, different fields that come out of it. We're using static in there with a radiant field. Things like that weren't even thought of back then. So all that, any diamagnetism isn't in that whole paper. Okay, so they're basically dealing with basic magnetic formula. And
Right.
that is a complete disaster for ether. You know what I mean? So
Yeah.
that's why it would fail. Now that we understand these things, it'll make a comeback because now you put all the puzzle pieces in place in order to form it correctly.
Right. Yep. Exactly. And it's, if you recall that guy we were talking about earlier about plasma containment in magnetic fields, that guy that physicist talks about the ether. So I'll get you that presentation. It's pretty good. But yeah, interesting, John Bigman. Interesting theory. All right, 3D Havoc says, what would happen if you took tape next to collect a thin layer of the inside of your bingo tumbler and then stack multiple tape layers with the charged glass together like a capacitor?
Would it stay as an electret that way, or does it lose charge?
I mean, this makes sense because capacitor and electret are the same thing. It's just that capacitor leaks its charge or discharges its charge, whereas electret keeps it. But if you build a powerful capacitor, let's say, and then figure out how to keep it stay there, no leakage, which is the binder that helps with that, what you were talking about, the beeswax. I think Jarvis sent me the exact wax. It's like carnauba wax. I think it's called carnauba wax. And so that's on my Amazon order list as a binder. But thanks for sharing 3D Havoc, because that's the goal.
So hold on. Why not
Yeah.
make it easier? Lay out the tape, pour the sand on it, right? Then lay out another piece of tape right on top of it, and then the sand again, and just layer it. Then put it in the tumbler. Once you already have your shape, you know what I mean, set out, and it's got all the layers on it, tumble that thing, see if it holds. I have a feeling that it's going to discharge like a capacitor because it's going to leak. That you're not trapping the fields in it. You're temporarily charging it. And I think it's more like a capacitor than it is a electret, but it's like an atom. They go, it's so funny. I think it's one of the things around physics right now. It's mostly empty. Well, yeah, because it's just fields being stuck together. That's all it is. All your little electrons don't really belong there. I'm sorry. My opinion. But it's all fields. And when you start mapping out the fields on each single one of your little protons and neutrons, you start finding out, oh my God, they just stick together like a little electrons, right? And their fields come right out of them, or like a magnet.
Right.
So that's just my thought.
I'm just trying to hold that concept in my head is, do I put a capacitor in the tumbler and then tumble it and then come out and it's charged? And that might lead to some methods of
seeing how fast it discharges.
Yeah.
See how much you could build it up and how much it discharges.
Exactly. John Bigham says, since hydrogen is the most common atom in our galaxy, then it stands to reason hydrogen is closer to the resonance with the ether. I think ether is invisible. Well, hydrogen's invisible too. That's interesting. That's an interesting comment. Thanks for sharing, John. Coke Creative Studio says, what? Of course, but you gotta have something to say. We're having fun here, man. You should too. Okay, thanks.
I don't think that was meant for you, Shawn.
Oh, I know. It looked like a question.
Yeah, okay. Total different subject.
Oh, Jarvis says it's carbaoba wax. Thank you. Yeah, that's what the standard electric guys use. I think the plasma channel used that wax. I wonder if it's similar to beeswax. Interesting. Okay, my wife's pantyhose is made of vinyl. Good to know.
Shawn, are you falling into the trap of reading anything on there?
I'm skipping a lot.
Huh.
I mean, it's fun to read the goofy ones, I guess. So
I'd have at it.
okay. So Jabber has a long sentence again. I think it's their conversation, but it's kind of fun, interesting. John, matter mass is a byproduct of electron spin, which is merely a measurement for the amount of longitudinal ether compression. Woo! These guys need to write a dictionary. Sounds good. All right. Ulysses says, I swear I saw Nathan at the swap meet with stocking on his head, laugh out loud.
It wasn't me.
Some street guy.
I like it though. That's funny.
That is funny. We should switch to humor now. All right, John says the length of the plasmoid strings determining the type of matter. Creative awareness says for ball lightning or EVO, you need charge separation, water vapor, and turbulence. Very interesting. Let's see. Jarvis says, Shawn, look at GR. General relativity. I read a lot. I know a lot about relativity. What's fascinating, there's a book out there where it says it'll teach you general relativity without calculus. So he just does it all in algebra. So it's high school algebra. And he teaches certain really interesting things like if you were in space and you had a pen and you put that pen 6 feet from you, you create a gravitational field. What they call it's a bend in the state, a curvature in space-time fabric. But literally, that pen will be attracted to you, and within a couple hours, it will be attached to you because you become a surface with gravity. And I never thought about space like that. I didn't know gravitational fields were that sensitive in space, but it makes sense because there's no atmosphere. You're in a vacuum. You have nothing, no sound, and no wind, and no nothing. So then there's no friction. I guess if we didn't have gravity, that wouldn't work either. But it's interesting, and general relativity shows how you bend the fabric of space-time. So general relativity has some good points. I think it's missing things, and I'm looking for the paper, the research paper where Einstein first hates ether and proves it wrong, and then before he dies, he writes a paper that he's for it. I'm looking for that paper.
Gotcha.
Jabber says mass is the ether in compression.
Mass is ether and compression. That makes a lot of sense.
It does.
We had talked about that. Is it physical mass, like like a rock or something like that, or is it energy as mass? And I think it's energy as mass, like he was saying. Compressed ether, yeah. Or the ether is compressing something else, like a static, in order to create mass.
So do you think that if ether creates mass, then what creates energy?
How do I say this?
Mm-hmm.
I think it has to do with the actual crystal, okay, the geodes. And I have a feeling that just something in the geodes, and it has to do with frequency. And it's the formation of it. And there has to be a magnetic aspect somewhere, whether that be in static or in magnetism. It has to be in there somewhere in order to create it.
I mean, we saw that behavior, right? Where I was electrocuting different materials and then when I brought the geode and it just lit up, it was offering its own energy from, do you remember that?
So I wanted to see that again. If you can ever pull it up again, maybe for next week. It it's such an interesting concept because I remember it going to the geode. I don't know that if the geode lit up
Uh-huh.
or anything else. So it'd be interesting to see again.
Yeah, it, so the other materials, I'll do that. I've written it down here. I'll do the experiment again. I got my geodes around the corner. I wanted to do it with some quartz crystals anyway that I picked up. So I'll start slamming some plasma into them. What surprised me about the geode was everything else seemed to kind of just be impervious. They just let themselves get hit by the plasma and there was nothing really happened. But when it hit the geode would light up with its own energy color. It had its own sort of spark, if you will, to almost push back.
So hold on. I gotta clarify here
Okay.
because it's a massive milestone there, and I've never met anybody to do it. You're telling me that the geode itself turned the energy on inside of it.
That's what it looked like. I'll do it again and show you. It just looked like you're not coming in here, plasma, and it's either that or it looked like it lit a lot of firecrackers. But it interacted with the plasma, and there's just, I mean, I don't have every rock, and tested it, but I had a bunch of stuff testing it, and the geode crystals were, they just, it looked like a lot of fireworks, but if you look at it closely, it's almost as if it's pushing the plasma away. So I'll do some filming of that for next week.
You do understand that this is the fundamentals of understanding energy of a planet, right? I mean, literally, as soon as you get that geode to light up, you know what I mean? Whether it's repulsing something or attracting something,
Yeah.
it's the fact that it lights up. I mean, think about the Ark of the Covenant. Think about the plate he wore. You know what I mean? The priest. And they actually lit up. I mean, that's the kind of level you're on when you're starting to light those things up, Shawn.
Wow, it's when the high priest would wear the vestiture of the 12 stones on his chest, symbolizing the 12 tribes of Israel. And then they had two stones, the Urim and the Thummim, and whatever they would seek God's answers. Some believe that the Urim and the Thummim, one of the rock stones would light up.
There you go.
And so I've never heard it parallel to what we're doing here. That's
well,
just from.
Think of what plasma is. Plasma is frequency. It's a magnetic field. Okay, whether it's inverse or not, it still is.
Yeah.
And then you have the plasma component to it. Now you can dial each one of them back individually, right?
Mm-hmm.
So you may not need, a bunch of purple plasma coming out to get this. It may be very clear, see through, and still pull off the result and getting that thing to really start up and run.
Interesting. You got me. I have a whole box of quartz and geodes, so you got me very interested. And I sent you a link, I think, where you get a bag of geodes for a couple bucks.
No, I got a big one behind me, Shawn.
Oh, you do? Can you show
me?
me?
Yeah.
Awesome. Wow, that's awesome. Wow, how much did that set you back? What did it cost?
It cost me $10.
What? Where?
Somebody was online and wanted to sell it quick, so they put $10 on it, and I don't think my truck could get there fast enough.
Oh man, that's awesome.
So yeah, that's why I was asking, because now I may have to build your coil in order just to see what you're seeing. Because
Yeah.
I mean, look, let me just say it this way: I truly believe that purple's in the center of the earth, and if we get the energy to continue in there with a natural circle formation like this,
Yeah.
see, I got the vortex hole already.
Mm.
Okay, if we get the energy to swirl inside here, man, the geode itself, based on the structure, is a natural geometry coil.
Right.
I mean, just think about that, because you're not looking at the individual crystals on the outside. You're looking at the oxygen formation on the inside.
Mm.
Now, my only question is, are we going to have to put some kind of water next to this thing, or is it doing it without it? You know what I mean? So
Oh,
you're
yeah.
essentially creating cold light, Shawn, if it's going off. Basically,
Mhm.
like a drill bit would do to this thing. If I put a drill bit into it, the whole thing would go off fire like firecrackers everywhere inside the whole thing, right?
Yeah,
And
it's the same thing with the plasma. Yeah.
but you're doing it. It only does that under pressure, heat. Okay, those are
Yep.
the two things they're doing. You put a drill bit in there. It's pressure and heat that you're
Yep.
creating in there, and then it sets it off. So there's something else you're doing to get that.
Well, I'll make some recordings and you can tell me what it's doing. Seems like you're an expert.
Oh, I've been
Oh,
studying this one for a long time, Sean. Wait until I find what comes across it. Let me tell you that right now.
okay. Well, hopefully this is the avenue. My coils be awesome.
Well, it's because of that field flip that you did. The tendrils make, like, it's so different than the sword sparks.
Right.
You got to understand, you got something different there, and every one of your round coils that you make, the
Yeah.
field's different. So
Right.
Tesla once supposed what the Earth's magnetosphere would look like, and just listen. It has a big bubble that comes out right here,
Right.
and then it comes around, right, and it looked exactly how you mapped your coil.
Interesting. That's
So
right.
he knew all about the cold energy, and he did the Tesla hairpin circuit. So you're using his energy with his
Yeah.
design of the ether in a different format, mind you, but now you're connecting with geodes. That's a massive understanding.
Right. Yeah. It's huge because the more I read about crystals like quartz, it it's if you do something mechanical, it will give you a voltage. But if you give it a voltage, it'll give you something mechanical. So there's give it voltage, it moves, or move it, it gets you a voltage. And because you're applying a frequency to that, now you're getting both. You're getting movement and energy. And so that's fascinating. And maybe that's what I did is when I was hitting the geode is it was this push pull action really fast. Um, but so fascinating. I'm gonna do it. I'm gonna figure it
So,
out, and then
well, hold on. Let's go down the rabbit hole a little bit. The,
okay,
the, the cold energy with water affects quartz. Okay. So the water may put a tiny bit of pressure on it. With the plasma that you're putting out, it may be a tiny bit of pressure because you're not in a compressurized environment, right? Like
right,
we're on the earth, which is a positive pressure, but you're not putting it in a chamber. So
right.
it could just be putting a little pressure on it that it needed. And the
Mm,
electricity needs something like that to flow. What would be interesting in running it in a while for a while and see if water attracts to it.
mm,
Something tells me that those elements all right there are all working in the same family to make these things work right.
mm.
Because as soon as I put it in water, I can find the frequency of it because it's putting off energy in its own, right? So
Yeah,
anytime something puts off energy, it puts off a frequency.
right.
So man, there's so much there. There's,
There is. I'm just writing things down. I'm learning a lot from you.
well, I'm learning from you, man. You got this one. This one's yours. So
Thank you. Wow, we're a big team because you'll point things out and I go, oh, and you explain it to me. Just appreciate it. Want to go through a couple more
Yeah,
questions?
keep going, Sean. You're good to go.
All right. Here we go. John Bigman, he did a lot of things with the mist and high voltage. At first, it was used to see the ionic wind of his high voltage rocket engine. This fascinates me, and I've been trying really hard to somehow see the fields around me. And you've tried too. Didn't you get a fog machine,
I have a fog
Nathan?
machine, yes.
And you didn't really see anything change, right? It didn't seem to have an effect.
Should I had a misting machine?
Oh, my wife has one to get out wrinkles out of her clothing.
So the difference is the two. It's like a dry fog when it comes out,
Yeah.
where the misting has that water in it, right? That's what you're looking for.
Uh-huh.
And the different fields interact with water in different ways.
Right.
So yeah, it would have been better with a misting machine.
I see. And I think they were like $15 on Amazon because my wife buys them for travel and it gets the wrinkles out of her business attire. But I didn't think about it. She has like 3 of them, so I'll play with that because that sounds really interesting. Using water droplets to see fields. I have another idea. I've ordered some stuff off Amazon, so hopefully I can share it with you, and it won't be flammable like my cloud chamber. I have the parts of the cloud chamber, but I don't feel like it's safe yet. So, and I have 37 active projects, and I'm just a cat with a laser pointer sometimes. Thanks
Joe
for
said,
sharing.
Joe said, by the way, to use my thermal camera. Okay, and we were talking about taking like a hair dryer or a heat gun, and when you create that field with the radiant energy and static,
Uh-huh.
see if the heat goes around it. Okay, in any way, it shows half a form, some form. You can always adjust the heat, but that was the thing, because if it's creating any kind of field that holds and changes the environment,
Mhm.
then the heat would be different, and you'd pick it up in the camera. It may look like it's going through, but there'd be 2 different levels of heat. You know what I
Right.
mean? Then, or there'd be heat coming around it. There's a lot to it. So that's why heat, mist, things like that, the cold, the heat, it's like a warm house on a cold day, and you open the window, and here comes all the energy.
Yeah. Um, oh boy, I had a question for you. It escaped my mind. Oh, the infrared. What kind of things have you captured on your infrared that's interesting?
Well, what's interesting is the shininess of stuff. It
Mm,
comes into that camera pretty easy. You can see through things because it's shiny. So
yeah.
I didn't realize that you could do that. So let me make a stupid analogy here for you. If I'm running around in my tinfoil suit, you could take the thermal camera and find me right through the
Yeah.
wall. Yeah, that's so great.
Have you tried pointing your infrared camera in a mirror?
No, I
Because
haven't.
even the light reflecting off your face creates little changes in heat on the mirror, and you get a heat signature. And so you see
Really?
you see the heat signature of your whole body on the mirror.
Oh, we were talking about that with another thing. There was a camera set up with a mirror, a convex mirror,
Uh-huh.
and the guy was able to see gases and stuff like that.
Oh,
Yeah, I'll send you the link to that one too. Man, I'm going to have to write down a
yes.
list. But he was able to see them in color. He put it with a red tint and a blue tint,
Hmm.
so that as the camera captured it, it would look either red or blue coming out of it. Absolutely amazing experiment. What kind of got me is the 2 colors were red and blue. So
Mm,
when you're sitting there in the theater watching the 3D, and they give you those little glasses with the red and blue in it,
yeah.
it's kind of like looking in there and that. You know what I mean?
Oh, yeah.
Well, at least to our eyes, anyway. Maybe that might be the effect, maybe not. But it's just what reminded me of it. But
It's
I think
is it a
that
hologram?
the convex mirror was the trick.
Hmm.
Yeah,
And did it put? Uh-huh.
there was a whole thing about it. There's an expensive version and there's a cell phone version. So, there's,
Oh,
so yeah, I'll have to find both of them and send them to you.
I dream of something that lets you see fields, all of our fields, and how they interact. It sounds like you're talking about some holographs.
Something
Um,
like that. I don't remember the name of it.
but to see field lines or particles or something in that, well, that'd be interesting. It'd be worth checking out.
Let me tell you this. If it showed the fields of that little gravity flyer, I would literally Shawn by the like 3-foot mirror, okay, and spend the money to do it no matter what it costs in order for everybody to see what I see or
Oh,
the what I
yeah.
know is there. It really is that important to what we're doing.
I believe you, and I'm just excited about it. I'm not excited that we can't see them all like you, um, but I'm trying this new method out. Let me see if it works, and we might be able to get the fields to show up from the gravity flyer. So I'm hopeful. Um, so Charlie C says, "Can you talk about the circuit here?" I think he's referring to the ZVS that I called Uber 3. Um, it's just a ZVS. The only thing I change is I remove everything unnecessary because most ZVSs have like 14 components, 16. You only need 10. And the reason why I have the 24 volts come in and then the power come in is that I never have to worry about the ZVS oscillating because the ZVSs are finicky and pains in the butt. That came from my one switch idea where you put the switch on the negative lead and it kicks the oscillations off. The 12 volts just do it perfectly. So my guess is that your 12 volts is touching something that might be shorting it. So I'd be glad to look at it. But if you recall from my last presentation, I do show so you can get a screenshot of the exact schematic of Uber 1, Uber 2, Uber 3.
Well,
So
I think sometimes you don't mention this, but you solder it sometimes, is what I noticed. And then you
yeah,
probably crimp it down a little bit if it's loose. And
yeah,
so
yeah,
if you say plug and play, people are probably thinking just put it right in the hole and leave it. You know what I mean? If it's loose a little bit, but every looseness creates a short. So
yeah. As long as things aren't touching, and I don't crimp because the hole's so small, it perfect for components. Absolutely perfect. So, and inside too, the copper is very protected, so it's very shiny. So it's a very good contact inside.
okay.
So yeah, it's I mean, I call them indestructible because I burned up so many ZBS boards. it's I just don't want them. Tired of making them, and I want to move to Electret. So I do want to keep the high voltage experiments going, but more of a side job. So Charlie, see, I'll work with you offline. I'll be able to answer all your questions. Thanks for coming though to the chat, to the presentation. It's great to see you.
Yeah, Charlie C is awesome, man.
He is the man. Anthony Williams. Let's see here. Plasma, a constantly changing circuit with resonant areas. If only we could see the magnetic fields changing as it happens. I kind of think we're saying that, right? He's saying that he wants to see the fields, magnetic fields as they're happening.
Oh yeah, yeah. Everybody wants to see that. Do you know how many problems would be solved if you could see static fields and magnetic fields in the air? Like every experiment in the world, like leakage, anything like that that comes out of it, would be solved to be able to account for it. If it is making a field around it, oh my God. Like the difference in tuning things in, it would
Yep.
be just extraordinary.
It would be, the tolerances of everything would be super tight, because you'd be seeing, like you said, distortions in magnetic fields, leakage. That, yeah, oh my goodness. My way is going to be two-dimensional, but I think two-dimensional is at least a start. But yeah, to see it three-dimensionally, oh my goodness.
Yeah, I'll be honest with you. That's one of those things. If it's a $5,000 setup, for even garage guys, if it showed your experiment proof of concept and everything else, it's going to be worth it. Or it's one of those things that they set up at a university and they allow you to come down and use it for a fee. I'd pay the fee. You know what I mean? It absolutely worth it.
Yeah, I've always wanted something like that, but I never thought it was possible. So I didn't really think about it. And when you pulled out your dry fog machine and your grab-a-flyer, and I just thought, man, if we could see all the fields, it kind of spurred me on at that point. So I've been experimenting. That's why I mentioned the cloud chamber. And I'll still finish it, but it's flammable and you don't want sparks near it. And yeah, so it's kind of not what I wanted.
It's like a bomb, man. That's what it is. We all know that. Yeah, not very friendly.
Yep. So Stefan says the Hutchinson boat experiment looked like ultrasonic to me. Also looked like powdered mica in the water at one point.
He's just building a hot field, right?
You said he's just building a hot field?
Well, okay, so anti-gravity field. Simple basics. You need a radiant field and a static field. Even Hutchinson knows that, so he tells you get a static generator, and he's telling you also you need this high-power Tesla coil. Well, on the hot side, it's got to go over 1 megahertz, right?
Mm-hmm.
Got to go over it consistently, no problem. You're going to need something that's like a light bulb in there, right? So that you can ionize things. Now, you don't ionize the air with just discharges of plasma. Mm-hmm. You're basically taking the Tesla coil and the discharge of it, putting it in a tube and ionizing it that way. It's just like the thunderstorm generator with the light bulb in the water. It's a simple ionization, right? So now you have a field. The static field gets held in by the magnetic field, or, you know what I mean? I call it the radiant field there, and it holds it in. Then the room itself plays a part, because depending on the size of your room, how far is the field actually building out? We're thinking it's a ball like this. It's not. It's a continuous sphere as they keep building. You know what I mean? And that's why it matters. All the stuff in his room, any metal walls, anything like that, adds to an outside magnetic confinement field. Mm-hmm. So, yeah, it's not that hard. He knows both sides of energy. Hutchinson does. You can tell because the growth of the plant has to be done in negative energy in the cold side. Yeah. And the changing of the sections of the plant has to happen on the cold side, can happen on the hot side. But he's definitely using hot energy in his anti-gravity experiments. And then it's simply how much can that item saturate with the static? That's basically what it is. So, and you would understand that if you did a static field experiment and you could make paper go from like a dielectric or something, or like a non-conductor, I should say, and make it into a semiconductor, and it applies force. Yeah. If you understood that, then you knew what he was doing.
Wow. Fascinating stuff. It seems like you have a deep understanding of Hutchinson's.
Oh, I do. It's applied for. How do I say this? When you do the right experiment, you have two plates, and you put the paper in between, and it'll suck to either side depending on how you do it and how you build it. And that's why it lifts that way. So anyway, I will leave it at that.
Have you tried to replicate any of his experiments?
I won't use the hot side of voltage like that.
Oh, okay.
Easier to pull off, worse for your health. It's
Oh, that's right. That's right.
yeah.
Makes sense.
So
I want to talk more about health, but
yeah,
maybe
well,
offline.
yeah, let's just put it this way: we get in a proper lab where it's not a problem.
Yeah.
Absolutely, I'll throw the switch myself. But
Hmm.
yeah, with no protection, there's no chance. I'm not going there.
That makes sense. I mean, safety first. You don't want to. You want to be healthy to be able to do your experiments and play with your grandkids. All right, Jabbers says, excuse me?
Go ahead.
Okay. Jabber says it's rather easy to turn water into hydrogen with ultrasonic transducer mist and capacitive discharge. You instantly split and turn it into explosive hydrogen. I've heard of splitting water into hydrogen using electricity,
Mm-hmm.
but this is saying using an ultrasonic transducer.
Mm.
Do you think it could do the same?
I've never done it that way, but let me think about it for a minute.
Yeah.
No, might be. It's one of those things that'll come to me later.
Yeah.
But you're using, you're preparing it with negative electricity, which would be in your transducer. In a closed, it depends if it's in the water or not. Well, maybe not. No, because it puts off a pulse wave.
But
I
it's
don't know that
sound.
I don't know that it splits it. So I'd have to
Yeah,
look more into it.
I don't know if sound waves are small enough to split them. I
Well,
think.
hold on. It depends on how you see that ultrasonic cleaner working. If you
Okay.
think that it's transmutating the water itself, okay, which most people just say it's vibrating the water. If you see it as a transformation in there, then you could see it breaking the molecule apart, right? The molecules apart, grabbing the dirt and holding them in and then taking it off of it, right? But if you
Mhm.
see it as simple vibration, then obviously you wouldn't see it that way. So
Yeah.
it depends how you saw the experiment and then you amplified that effect.
Hmm. It's a really interesting theory because you're not going to have sparks, and electricity gives sparks because you don't want sparks around hydrogen. So if you could use ultrasound, then you remove the sparks from the area of the creation of them. So that sounds fascinating. It just seems like a safer way to create hydrogen.
Well, I don't know. It, yeah, I guess. I don't think you use 5 volts to split it. I mean, you can take a 9-volt battery, put it in there, and we can split it. It's not the hard part of the whole experiment. So you don't need necessarily all that. What people don't understand is you got to magnetize the oxygen. You have to pull it in its form once it's split away from everything. And if you don't, it recombines right away. So
Interesting.
it's not so much how you split it, it's how you separate it. And if you don't have an efficiency process in separating it,
Mm-hmm.
and then you also need to look at if it's the energy comes from splitting it or combining it
Mm-hmm.
versus the elements that you're getting. It may not be the effect that you're initially looking for is what you need to find.
Mm.
I'll say that about those things. You may want to look a little closer at it.
Okay. I'm always taking notes when we speak. So much good stuff.
Well, you got to remember his patent, right? So you have these three, I think it's three or four chambers, like little tubes as they go through, and he's magnetically putting coils on it. So it basically, that right there, it doesn't affect the hydrogen, but it affects the oxygen. So it's literally filtering out the oxygen at that point and letting the hydrogen pass. Yeah. So, I mean, think about it that way. That's what he's doing. It wasn't, rocket science to figure that part out, but that's what he did.
Amazing. I thought because the sound, so if you're running electricity, you're taking electrons and smacking them into other atoms. So you have this sort of molecular particle hitting another electrical particle and breaking the bonds. But to jiggle them with ultrasound, to shake them apart, that just seems more difficult in my head. But like you said, I'm seeing it in the different way. If I look at it how you explained it, then that problem is gone.
Well, how about this way? It may be 100% right. So if you create a magnetic coil, right, and you put it in the water and you start to get the conversion going, right? But then you put an ultrasound to it. Now it's an ultrasound pulse. So you're not just getting the resonant frequency, you're getting the resident frequency. You're getting the three parts that you need, right? So think of it this way. The amount of it barely pulling off and separating, the ultrasound comes along and hits it and it blows apart. Okay? Just like that. So in the amount of time that it takes to do that, the faster that you can get that going, you know what I mean? Separation, boom. Separation, boom. You know what I mean?
Right.
You're going to create a much stronger amount of everything.
And that's with a transducer.
Yeah.
Or a piezo.
It's a pulse wave. It's like water hammer. It's literally a pulse wave.
You know so much. I'm learning. So creating awareness, says Shawn, should look up ENG8. Do you know what that means?
No, I'll have to look it up myself.
Yeah, I'll have to look it up. Thank you. I'll look it up. John Bigman says I killed my camera. Yep. 3D Havoc says I'm transmitting from the 80s, 1980s.
Here you go right here. Apparently, John Keeley in the 1890s put water down to 27 levels using ultrasound. So there you go. I always trust what Ian says. So
apparently, John Keeley in the 18th split water down 27 level. I see. So you have to kind of like run it like a waterfall or water down a staircase. And there's 27 stairs. And it just keeps pulling, each stair keeps pulling, and then boom, it breaks the water molecules. That's interesting. Ian's smart. Ian says something right once in a while. I mean,
Ian said stuff right all the time. Don't even fool yourself.
I proved him wrong a couple times, but he's mostly right. I'm just teasing him. He's a helicopter pilot. He's brilliant.
Oh yeah.
He always questions, like you said, everything. He'll question it.
Oh,
see if you really know what you're talking about.
It's okay. So here's the way I see it. If you have a novel, you only give him a portion of the novel because he's going to come back and ask you for the rest of the novel. You know what I mean? Because he knows it's there. Trust me when I tell you that. With talking to Ian, he has everything down, and he will build everything that you do and verify what you're saying. There's no question about that.
That's right.
Yeah, we're all big fans of Ian.
Jarvis says he's a fanboy of Ian. A little bromance going on there.
So EM8 is energy. Okay, but I think we're still missing something there, or maybe it's just a different way to say it in shorthand.
Yeah, I guess. I'll have to look it up. John Bigman says all that unclean impulses killed it. You talking about my camera? Michael
It
Merrick
might apply
says,
to your camera.
yeah. In the ether model, matter and antimatter are not distinct, opposing entities annihilating into nothingness, but rather polarized states of dielectric ether. They represent structural imbalances in, he continues in a new one, the ether's field dynamics, where different configurations of charge, dielectric stress, and rotational inertia define their behavior. Wow.
So basically, everything breaks into nothing except for its original state and then recombines out the other end. That's the way I took that statement, but you could take it any other way. We know that you're going to deconstruct it down one side and then reconstruct it over the other. And it's going to go down to its base elements in the center, and it's going to be a null zone.
Is that like a white hole? You've heard of black holes where everything gets sucked in and compressed, but a white hole, everything comes out reordered and gets more order and comes out complete functioning. Have you ever heard of that theory?
Yeah, I have. One's constructive, one's destructive. In 180 degrees out of phase in your universe, that makes sense.
Does.
I mean, if you're tearing stuff apart in one and building it back together in the other, that absolutely makes the most sense in the universe.
Does.
No, I just wouldn't want to be in the splatter zone.
What if I don't exist? This camera is not showing me because you know how vampires can't be seen in a mirror?
So play with the silver then, Shawn. So make sure no wood sticks exist in your house. You know what I mean?
Fall down on a pointy stick.
Oh yeah. Don't forget about the garlic. You don't like garlic, do you?
I love garlic.
Well, that ruins that.
I'm woefully behind in the comments. I'm reading comments from 502 and 612. I'll speed up, guys. Sorry. Conversations that have already been completed, I'm reading. All right. The question says, it's amazing that every particle has intelligence that knows how to be itself.
Okay.
I was looking for your opinion. Okay.
I think they're Klingons. They just cling on to anything that they can find. And once they find a structure they like, then they sit there and they stay. Unless something powerful blows them apart and reconstructs them. I think that's about the way it works.
Makes sense. Makes sense. All right. John Gray. You there, Shawn. I can see you. Oh. Okay, that's good. Daniel Foster, the space elevator idea needs to be paired with the Bucky Fuller floating city idea on both ends and from Earth to the moon because it would also be a tremendous generator. They're laughing at Klingons. But if you already have energy and you can recharge the battery, just make DC motor and replace the engine. That's from Ghassan Al-Badawi. Michael Merrick is like Jabber. He has these big, wordy sentences. In the ether model, black holes and white holes are not singularities of infinite density, but rather highly polarized dielectric disturbances in the ether field. These phenomena emerge from extreme, now a whole new one, stress and torsion with the ether forming regions of intense energy, compression, black hole, or release, white hole. Kind of sounds like what you were saying. Combine that with Klingons and you guys agree.
They release out of the black hole or the white hole?
White hole.
So it gives life out the white hole, but it's an altogether destructive experience out of the black hole.
Right.
Yeah. Sounds like life.
Jar Jar says he loves you. Loves me. Love you too, Jar Jar.
He says, oh, there you go.
Toilet
paper for Uranus. That's what the black hole is.
Oh dear, I was waiting for the third one, the butthole, but no one said it.
Oh, they're referencing it.
Our humor was going to turn to junior high level. I knew it.
Hey, trust me, Shawn. At this point in the conversation, if I was in chat, that would always be. That's my job. That'll make people laugh.
Yes. You always make me laugh. All right. To get more info on holes. You said the butthole. Yeah, I know. I was waiting for it.
Oh.
Let's see. Ian likes Michael Merrick's Heramine's description of this. Heramine's.
Pyramid or paradigm?
Paradigms, yeah. Haram, Haram, EINS, Heramine's. Yeah, a lot of fun, a lot of laughing. Everybody seems happy. Ooh, I've gone past my time limit. I'm having so much fun, Nathan. I really am. I love it. I love it.
You gonna go a little more, Shawn, or are you done?
Yeah, I have to take a medication on time, so.
Nope, I understand.
But I appreciate you letting me do this. I love your channel.
Hey, Shawn, you got it in reverse, brother. We owe you for coming on here. That's the way it works.
Oh, thank you. Man, you made my day. Made my day. I'll tell you, I smile for a week. And the only reason why it's a week is because I start again Wednesday to recharge it. So, all right, Nathan. Thank you guys. And you guys have been wonderful in the chat. Wow, 57 of you hung out with us.
All right, guys. Shawn, let me give you a round of applause here.
Appreciate
guys, that was awesome.
Thank you, guys. Well, we'll talk again at that same bat time on the same bat channel.
All right, Shawn, give me a second. Let me close it down. I want to thank everybody in the chat. I want to thank Shawn here for presenting today. Man, such an awesome show. I look forward to Wednesdays myself. Thank you, Shawn. Everybody in the chat, have a great night.
All right. Much love. God bless.